Okay, hey everybody. I just arrived from Berlin. I'm super excited. It's my first time in Ukraine and in Kyiv. And I met Dimitri a few months back when I organized Germany's first LegalTech hackathon, where we tried to bring lawyers and software developers together and bring them together in a way so that they can create innovative ideas in the area of legal tech. And Dimitri flew to Berlin together with two of his friends, and they were one of the really successful teams at the hackathon. They developed a chatbot that increases access to justice by resolving consumer rights. And I'm very honored that he invited me to be here today and speak to you. So, as Dimitri said, I'm specialized in blockchain. I'm a lawyer on the one hand, but before I became a lawyer, I was already a software developer for many years. And like 4 or 5 years ago, I was trying to find a way out of becoming a lawyer. And I thought maybe looking into technology and law and how you can combine it would give me a way out. And at that time, the idea of blockchain technology being a new fundamentally new innovation in law came up. And I looked into this and I got really excited and I dove into it, and until this day I'm working really deeply in this topic, and today I want to share some insights with you. I only have 15 minutes, but I have 40 slides, so I will skip through most of them. I'm really sorry for that. So foundational technologies in law. Today we're pretty much used to this. We use paper and the fax machine, and that's the state of the art. And we all know that this has to change. And I challenge you to assume that maybe this is the new foundational technology of tomorrow. What is this? Well, this is the image, the metaphor that The Economist gave to the blockchain in its special issue on blockchain technology 1.5 years ago. And interestingly, you can see in this picture that blockchain technology really has no face. There's really no image you can put on blockchain technology. It's really an abstract thing. It's a back-end technology. That means it's running somewhere in the background. It's not an app on your phone. It's not like classical software that you know. It's something fundamentally new, and that's why it's kind of challenging for lawyers who are not that technically inclined to get a real idea of what it is, and that's what I want to try to give to you today. You can also see in this picture what The Economist used here. On the right you can see the logo of Bitcoin. Bitcoin was the first blockchain out there. It's now 8 years old. Today, Bitcoin blockchain holds $40 billion of value. So there's a massive interest in the network and in the technology around it. But there have been many different kinds of blockchain being invented since 2008 when Bitcoin made its entry into the scene. And it's become increasingly difficult to actually define what blockchain really is. There are thousands of startups now that do something and they all claim it's blockchain, but they all do something different. But since we're all lawyers, we want a good definition in order to get working with it. So the most general definition of a blockchain that I could come up with is this. A blockchain is an immutable, append-only database, okay? And you can record any kind of digital information in this database. It could be information about land titles. It could be information about what you save in a company registry. It could be information about royalties for musicians. It could be anything, right? And the interesting thing about this database is that it's not just running on a single computer, on a single server, in a single data center belonging to one company, but it's a database that is shared in a huge global network of participants. Okay, so it's replicated all over the globe. And the twist behind it, which makes it interesting to us lawyers, is that there is an agreement between all the participants in such a blockchain network that whatever is written in this database is true, okay? Whatever is in this database is a fact to the people that participate in this network. You could also call it legally binding, okay? So in essence, blockchains turn digital data into facts. And in order to distinguish between all those hundreds of different blockchains that exist now out there, you can really use this handy picture here. There is fundamentally blockchains, I'm sorry for the German word here that means, so this one here that means public. So blockchains can be either public or private, or they can be permissioned or permissionless, okay? So the blockchains that we've all heard about, Bitcoin, and maybe you've heard of Ethereum too, it's the second biggest blockchain now. It holds, I think today it holds $18 billion of value inside currently. They are blockchains that are both public, so everybody can access it, and they are permissionless, meaning there is no single person on the planet that has special administrative rights in this network. There's no admin, there's nobody that can change anything if they just want it, okay? So it's kind of like an uncensorable, uncontrollable global network that holds a lot of value. And a few years back, when the banks heard about Bitcoin and heard that there are big deals being done with it, people can transfer money without an intermediary and so on, they looked at it and they realized that could be interesting to us too. Maybe we could upgrade our financial IT infrastructure with this technology. But of course, banks don't want networks that nobody controls and where they don't have special access to. So they developed their own flavor of blockchain, which is also becoming more and more popular now, which you see in the bottom right corner. So those blockchains are not public but private, and they are not permissionless but permissioned, okay? And there are two big companies in this space. They've been both bought up by IBM now, actually. They're called Monex and Hyperledger, but it's basically IBM. And there's a new hybrid form of blockchain coming up now, which is public, but at the same time permissioned. Okay, so meaning it's like a classical IT system where you have an administrator running the system, but at the same time it tries to be publicly accessible to everybody. And this is a big chain that's a Berlin startup actually, and Ripple, which is a huge cryptocurrency. It's the third biggest cryptocurrency, holding something like, I think, $17 billion of value right now. How do you generate trust in a blockchain? Because that's what it's all about, right? You want a big global public trustable infrastructure where people can transfer money, save their money, and so on. And fundamentally, we have two different concepts of how that can work. In the permissionless blockchain, so Bitcoin and Ethereum and so on, we have an interesting mechanism called Nakamoto consensus. What is Nakamoto consensus is what you've heard as proof of work, mining, all those things. It's basically a mechanism to allow thousands of anonymous agents in a network to come to an agreement on the state of that blockchain database that they all share. Okay, it's a consensus mechanism that works without having to know the identity of anybody in the network. And this is really a revolutionary invention that was pivoted by Bitcoin and has been copied by all the blockchains that came after it. Ethereum and all those other blockchains, they all use this proof of work based consensus that in general we call Nakamoto consensus. Now what the banks do and the insurance companies and all those companies that you hear that are doing blockchain now, they don't do this because they can't control it. So they do something that is much more akin to classical IT infrastructure as we know it, meaning you have a set of companies whose identities are known, and those companies decide that they want to run a blockchain network together. And they close classical legal contracts among themselves where they define what kind of network they want to run, what it's going to look like, who has which duties and who has which rights in this network. And then they codify parts of those legal contracts into a protocol. And then they jointly execute that protocol together and thereby creating a blockchain. And that kind of sounds boring, but it's still interesting because essentially what you do is you standardize the transactional layer on which those companies then do economic exchanges. Okay, so it's about standardization much more than about a trustless interaction between agents in that network. But that can still have huge economic benefits, obviously. In order to make this a bit more kind of visually understandable for you, you can read the slide from the bottom up. So how do you create a Bitcoin-like public and permissionless network? Basically, you have thousands of people that execute a certain software on their computer all over the globe at the same time. And the joint execution of this software, which is an implementation of a blockchain protocol, creates an emergent universal trust infrastructure that is best compared to a public good. So like the air and the seas, it's something that is just there, that it can be used by anybody, but that is controlled by nobody. And this is really a fundamentally new thing in the world, and nobody really knows what it means and what the legal implications are, right? There's hardly any regulation around blockchains. There is some anti-money laundering regulation, obviously, because it's quite easy to launder money with it. So the European Union has modified its anti-money laundering directive in order to regulate exchanges where you can convert your fiat currency into cryptocurrency and so on. But beyond that, there's just no regulation on it because it's a new beast and the regulators don't understand it, meaning the lawyers don't understand it. And opposed to this, in this private and permission scheme, what the banks are doing, you don't have private individuals creating this blockchain network, but you rather have banks, companies, big corporations executing a certain software in the data centers together, creating this shared trust infrastructure between a number of organizations, which, as I said, is still fundamentally interesting because it standardizes the economic transactions among those companies, okay? Which translates into breaking up the data silos that the companies are still today.
Florian, can you be wrapping up a little bit? Like,
yes.
Like 3 minutes or so?
Yes, so, okay, I will just finish with this slide, which for me kind of sums up the disruptive potential of this technology. You read it from the top left. The pictures you see here, they are so-called network topologies. Okay, they show you how do the participants of a network send messages, communicate with one another. And on our IT infrastructure today has a so-called centralized network topology, meaning that every message that anybody sends, any data package, has to pass through a centralized intermediary who you have to trust that he really delivers that message, that he doesn't modify the message, and so on. Now, what blockchain allows us is to move from a centralized infrastructure to a decentralized infrastructure. There is no central intermediary anymore that taxes your transactions, that controls and senses your transactions. Now, on the level of bookkeeping, yeah, today we live in a decentralized world, meaning every company has their own books. For that reason, we have a whole industry of auditors, lawyers, and so on that make sure that the company's books are actually in sync. If company A pays something to company B, it has to be an income in the book of company B. Okay. Now, because we're moving our IT infrastructure to blockchain, we can centralize the bookkeeping. So the whole industry of the bookkeepers, of the auditors, of the lawyers is not needed anymore because their job is a base function of the protocol that we use to transfer value. Okay? So that's my short introduction to blockchain. Thanks.